The effects of reindexing. Well, the effects of reindexing is that it has no effect. And it is blindingly obvious once you understand what reindexing really is. Let's imagine that we have a series. N is equal to 1 to infinity, and we'll make this series, I don't know, let's make it something. I'll use the example from the book. N minus 1. Okay, that's a perfectly good series, and it either converges or diverges, whatever. But when we say reindex, what do we mean? Well, when we reindex, we're going to do something to these n terms. Okay, not to go n is equal to 1 to infinity, we're going to make it indexed over a different range. So let's just say we're going to sum over n is equal to 0 to infinity. Aha! What's that going to do? Well, but we rewrite the equation to accommodate the change in indexing, so this now becomes 1 over 2 raised to the, can you see what would happen here? If we're going to change the range from n is equal to 1 to start to n is equal to 0, we would change the exponent to, see that? N. When you plug in 1, you get n minus 1 is 0. But now down here we just plug in 0, and we don't need the minus 1. And these things are equal. Well, of course they are. We made them equal. Now, what about this? What about this series? N is equal to 5. Aha! And this is going to be 1 over 2 raised to the what power is this going to be? Well, if we want to make it exactly equal, and that's all we're doing when we're reindexing, we're going to change the index, but we're going to keep everything else the same, so we have to rewrite the equation. This is to n minus 5. Now, the partial sums and the convergence and divergence, they don't change at all. These are all equivalent to one another. They're all the same thing. And that's all that reindexing is really talking about. It's just we change this number where it stops and starts from, but then we have to rewrite the equation to accommodate that change. And of course that has no effect.